One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. So today we are going to be looking at the kth star or the kth closest star, and yeah, we are going to see how we solve we solve this problem, and this will help us to see the waste, see where the optimization is. When we make the optimization, we truly see, okay, this is what the difference was. So but yeah, just in my video from yesterday, this basically illustrates exactly what we don't want to do in the sense of solving the problem. That's what we do here, so that we see what we are trying to avoid, as against then going to solve for the proper one. That's the optimization. Now we are going to be looking at the file. So we are going to take it again that the file is coming in. Okay, actually, I'm not sure I showed this yesterday, but yeah, so the file is coming in as a list, right? And basically the stars, right? And the star is going to be a list of tuples, and each tuple will have an integer, and then that integer would have a list of integers within it. So let's see what a typical example will look like. That means my typing is wrong because it should be a string, right? So we correct that. So this is like the name of the star, and then this is the location of the star, you get, or like, yeah, the coordinates of the star, right? So this ideally here should be a list of strings, right? So having said that, what does it return? It returns a list. So you can type here as well, say a list. Now having said that, let's get into it. So we define a star, we define a, I say star, a list obviously, and that list, then goes ahead to say ID and star in file. Basically, it's taking out the first piece, which is the star name, and then the stars distance, and then yeah, distance tuple, because it's a tuple, it's a list of uh um integers. So rather the lists, what am I saying? The stars list. So these guys is picking them out one after the other from the for loop. So that's why I'm saying ID for the name and stars for the list of their coordinates, right? And then we go ahead to see distance equals to distance equals to star. So remember the distance function we saw earlier when we were trying to establish the problem we're solving today. And yeah, we call this distance because of, yeah, getting it linearized, because obviously it's going to be all over the place with its different coordinates, but we're trying to linearize it so that we have something comparable between them. Now, between stars obviously, and then we say star distance, then we append that into our star distance list, and after doing that we go ahead to sort. Now sort gives us a sorted list showing us the one that is the closest to the one that's the farthest, and then we return just from 0 up to the kth value. So if we had 6 stars on the file and we just wanted to see the first 3, we'll just take from 0 to the third one, and we are golden. And that's basically the solving, the code illustration today for today. So we've seen the code illustration, and yeah, tomorrow we are going to go ahead to see how. So we are going to go ahead to see how we see it graphically. Although this is like trying to show the waste, we want to really show this waste, that this guy over here is also trying to show us we have different complexity for each of the stages right here, because we see that the star complexity is log n of O of log n, because that's what sorts the sort uses. This is like for loop, it goes through the entire file, and this is the k, it goes through the first k term that we want. So we'll now see where the waste comes in the next one. So yeah, the next one will be of the graphical illustration, my favorite guy, that basically helps us visualize everything that we are doing and basically have that mental picture of what we are doing. So yeah, see you on that one. Muchas gracias. Bye. Bye.